Hello everyone and welcome back. My name is Mr. Cobalt, and in this video we're going to go over complex ion equilibria. So what is a complex ion? So a complex ion involves primarily transition elements. Why do they involve transition elements? Because a transition element is a good electron acceptor, or what is also known as a Lewis acid. The transition element is able to accept electrons, and so then you have things like water molecules that can act as electron donors. So they have these lone pairs on them. They can donate those electrons to the empty orbitals, or say d orbitals, that are on the transition elements. Remember, transition elements have these d orbitals, and so you can add electrons to them. And so if you have anything that has a Lewis, that has an electron donor or acts as a Lewis base, can then uh, bind to the transition element. And so, for example, water molecules can act as electron donors. And so here we have an example of silver. So silver can bind with water. So if you have silver ions in water, they'll bind with the water. The water molecules will bind, and you'll get this complex here. This is your complex ion because it's got these ligands, and I'll explain ligands in a moment. It's got the water bound, two water molecules bound to the silver ion, and so it's got an overall charge of a +1. So silver plus, Ag plus by itself doesn't really exist in solution. It's in the complex ion form. So what is a complex ion? It's basically you have a central metal ion that is bound to one or more ligands. What is a ligand? A ligand is a neutral molecule or some ion that can act as a Lewis base, meaning that it's got lone pairs with the central metal atom. So it can bind with the central metal atom. So the other thing to note is if you have a stronger Lewis base, if you throw that in, it will replace a weaker one in the complex. So for example, let's take our silver ion that has the complex with water. So we have this complex ion here, and we throw in some ammonia. So ammonia is a stronger base than water. So it's got lone pairs on the nitrogen. So it's going to then replace the water molecules in the complex. So now you have a silver ammonia complex. So you have two ammonia molecules bound with the central ion or central metal here with a plus charge again. And the two water molecules are left to separate and float, be by themselves. So we can simplify this equation by removing water. So getting rid of the water. So we have Ag plus bind, and we have two ammonia. That's going to bind together to form the complex here. And this Kf value is equal to 1.7 times 10 to the 7. So this K sub F, just like with any equilibrium constant, we've had acid constants. So we had acid or what it was called acid, the Ka. So your ionization constant of the acid. You had your Kb, the ionization constant of bases. You had your equilibrium constant, and now we also have. Oh, and by the way, we also had we had another equilibrium constant as well. So with Kf, that's basically your formation constant for this equilibrium, the formation of your complex ion. And you'll notice that the complex ion, the Kf, is 1.7 times 10 to the 7. That's very, very large and highly favored. So this means that the formation of your complex ion is very favored, and most of the complex ions that that are formed, you'll find that the Kf values are quite large, and therefore the formation of those complex ions are favored. So again, for your any equilibrium constant, like your Ka or your Kb or your Ksp, your solubility product constant, they're all related to equilibrium. And so again, your Kf is also related to equilibrium because it's the equilibrium between the silver and the ammonia, for example, versus the complex ions. So there's an equilibrium here. So therefore, you have an equilibrium expression. And we call this the formation constant expression. So again, just like any equilibrium expression, it's going to be the concentration of the product raised to its coefficient as a superscript or exponent, and then divided by the concentration of the reactants here. So this is your Kf expression. So I hope this is helpful. I hope this was understandable with regard to what a complex ion is and the complex ion equilibria. If you enjoyed this video and it clarified and you learned anything from it, please, by all means, please hit that like button right there. Also, subscribe to my channel. Hit that notification bell right up there so you can be notified by other videos I put out. And also put a comment down in the comment section below. Let me know what you think and if you have any questions. I like to answer questions. Thanks for joining me and have a great day.